Alrighty, hello folks. It is time for the stream, the release stream of EmberGen 0.5.5.0. Our naming convention is interesting. But anyway, yeah, so 0.5.5. Some really cool stuff that we released last night. Got the build out. You can see here some of the glorious things. Oh, whoops, my camera thing flew down. Okay. Anyway, so we released some pretty glorious things last night. Somebody says that I'm late. Yes, I am a little bit late, but here we are. So anyway, we got GPU particles in, and this stream is just going to kind of go over our release notes, the things that changed, and how to use GPU particles and get you kickstarted so that you can go on and make your own things with this excellent new feature. It's really, really easy, and so we'll have a lot of fun today making some stuff and showing you how to use it. EmberGen open source, nope. Not gonna happen. So anyway, within this, let me go ahead and load up our website release notes real quick. And so we'll bring this thingamajig over here. And so should be able to see this. We'll go to our release notes, and you can simulate millions of particles now. Our changelog, we added in the experimental GPU particles, and within that we included a ton of new presets. So if you go to your presets folder and you scroll down, all of these ones that say GPUP on them, GPUP, they're the ones that are all the new particle effects. So you can see here you got like a poison shockwave, you've got let's see, like this crazy planet explosion that I made, and just a number of other things. Plenty of things to play with and mess around with and see how we did it. And so some really cool new presets there. And then we also reworked the alpha blending for exports. So for those of you, so let me just go to a new preset real quick. So for those of you who use flipbooks, let's just say we want to do this right here, and we'll just, I don't know, render straight from here real quick. So we'll go ahead and do an export now. So we can see this. What we have is we have the ability to change the background color of individual textures in here. So really cool stuff. It allows you to basically just change your background color so that you don't get black edges and things like that whenever you're exporting your flipbooks. And we wanted to make sure that we added that right within this this current what do you call it, the image export node. And then also part 2 of that is previously your alpha channels would be just like completely white, but they shouldn't be anymore, right? So you can see that we have fixed that. Previously, if you had like atmosphere or uniform background color or whatever, the background would show up as just completely white. And that was obviously not what you want for your exports. So we fixed that bug. And then individual windows can now be resized. So if we go to our ray tracer view here, you can see that you can indeed resize your windows. So if you want to see your simulations in a higher fidelity, more screen space or whatever, you are free to do so now. And hopefully we'll have like movable and dockable windows and stuff like that so that you can rearrange this. But for now, this is much better than just something that's static, and hopefully you can get something that works a little bit better for your setups. So yep, so we've got that in. Let's see, other than that, we had have it so that if you're in the export mode and say we go over here to our export and let's make this background black real quick so that we can see what we're doing. And so we do this, and what you can do, or at least what you could do previously, I don't know if it works anymore. Oh yeah, it does. It's just the changes aren't too big to see. But anyway, I'm using my scroll wheel and this whole thing zooms in and out. Previously that would move your camera, but it does not anymore. So you can successfully preview your stuff and do that. Somebody says, is it possible to change your FOV? Yes. Go into your camera and you have a field of view slider right here. So you are free to change your field of view. By default, it is 60 degrees, but you can change it to whatever you want. We also have perspective and orthographic modes. I just stick with perspective, but you do have orthographic projection as well if you want that. The next thing in our change list, we added a basic logging system. Daily encoded logs should appear in the log folder. I'm guessing that that's to like track crashes and stuff. I personally don't know. Somebody on our dev team is in the chat. They can explain that one, but I think it has to do with crash logs and shader logs and stuff like that, so that if you have a problem, you can send us that log and we can figure out what's wrong. Added basic tiled rendering. So this is really good for people who like to export frames that are 4K by 4K or 8K by 8K, whatever. So if you're the kind of person who just wants to export gigantic singular frames, and the software was crashing previously because of Windows, it was Windows' fault, not ours. Essentially, it would just get hung up. Windows would say, oh, I thought the GPU crashed, and so I just closed the software for you. The GPU never did crash. It just took a while to generate that singular file because we were doing it all at once. But now we have a tiled renderer, which makes sure that the GPU doesn't hang up for as long, and so it should be a little bit faster and make sure that Windows does not crash anymore. Let's see. Then we have an option to pause the simulation when all export nodes are done. Yep. So previously, like say you're doing something that's like really crazy, which I don't know where this setting is. Somebody have to tell me if it's actually in. I don't know where this setting is, but what it is let's see here. Oh yeah, pause after exporting. I figured it would be in this. So basically, if you're running your exporter, if we do this, and we'll say here, export image, and we want to do export now, we'll test it, see if it works. Boom, now the simulation's paused. And if you're running like a really complex sim that's, 500 million voxels or something, and you don't want that to continue on and on and on, that will just pause it for you so that your viewport can be interactive again. So really nice feature there. And so that's there for you now if you choose to use it. We're almost done here, and then we'll hop into the good stuff with GPU particles. So improved node graph interaction. Don't really know what that is, but we did. And then improve the window title refresh rate. There was a problem up here where the window wouldn't refresh and like your preset name would get stuck and things like that. So we fixed that. And then we added 19 new presets for a total of 104, which unfortunately my 104th preset didn't get added to the build for some reason. Tragic. but we went ahead and did that. Somebody said, how high quality can you go for the renders? I guess the question is, how high quality can your GPU handle? One thing I'll show is, I think it's the highest quality preset that we have in terms of voxel resolution and things like that. This right here is pretty much peak EmberGen for now, right this second. This particular volume. You could do higher upscaling. So if you go into your simulation, you can upscale this, but I don't think that upscaling would help this particular volume any more than what you already see here. And then for your volumes, if you want to increase your fidelity, you can also use sharpening here. So we can sharpen the smoke like 2500%. You get deeper shadows, more details, all that stuff, and all that can export with your VDBs or whatever. So yeah. So hopefully that helps you out. Somebody said, can EmberGen run on AMD GPUs? Yes, it can. Let's see. You can't do the framing in the preview anymore. You should be able to. So if you go here, there you go. So yes, you can still frame. It's just if you're exporting, it's not going to zoom in and out. But yes, you can of course still frame in your preview viewport. Obviously, we wouldn't remove that feature. Let's see. Very nice improvements. Are you still looking for a VFX artist? Yes, we've received, I don't know, maybe 20 applications, of which maybe 5 are good. The reason I say that is it's not that their work wasn't good. It's just that their work isn't particularly in our domain. So, it might be like cloth simulations or whatever. And we want somebody who has simulation experience and then preferably games experience. If we can't find somebody with games, we'll go with somebody who knows film. So if you are like a film CG artist and you do simulations and explosions and destruction and all the cool stuff, that's the kind of person we want, and apply for our role, and we will see if you're a good fit. So we'll see. We'll go ahead and probably review all of our applications sometime next week and kind of pick and choose and email people. If we don't accept you, we'll email you anyway, because we are courteous and we want to let you know if you're not a fit, so that you're not wondering and you have to email us later or whatever asking about it. So yeah, so that's coming up. Let's see some other stuff. Lovely stuff. Wow, that volume exploded. It is nice. Which actually my 104th preset that I'm supposed to add, I don't know if I can find it. Where's it at? Let's see. I'm looking for it. It'd probably be under this beta folder, maybe. Nope. Presets. I want to show you the 104th. Here we go. Volcano V2. So this was what I was going to add. I felt like this was much cooler shading for some reason. It's a very nice like subsurface light scattering look. So this right here was the preset that was supposed to be added, which I think that this right here is probably my best volume shader ever. Personally, I really like this, and it looks so good. And so this was supposed to be added in our next update. We'll add this preset in. But yeah, so this is really nice. Unfortunately, I wish I had like a 2080 Ti or something so I could run this much faster, but my 1080 is chugging to keep up with this. But anyway, so this right here is a really solid shading, and so I like this. It's probably one of my favorite shadings here. So let's see. We'll continue answering a couple more questions, and then I'm going to go into GPU particles, and we'll dive into that. But we got some time here. Let's see. Can you import models with animation and FBX? A little Limbic for The Sims? Not yet. We get asked that every single stream. I get asked that every single day. Emails pile up in my inbox asking me when it's coming. Big studios, small studios, individuals. Every single person who comes through asks about animated meshes. They're going to come up eventually, whenever it's done. After we finish up our GPU particles implementation stuff, we're working on camera imports next. Hooray, right? Hooray. We're working on camera imports, and then we're going to work on animated meshes. It's probably going to be a couple months, a few months, maybe end of the year. I don't know. It's not a very easy thing to do, but we do have plans to get it done and get with it. So with that, let's see. Go back to my presets here. We'll open up a GPU particle, and maybe we'll do this water splash. You guys are like, where's my liquids? This is not a liquid, I assure you, but it looks like one. It's pretty cool. So anyway, let's see. Is it possible to have longer shutter speed for more abstract looks? No, but you can suggest it on our forum or something so that we ensure that we add it in as something. I mean, it might be a thing that we could add. We do have like some motion blur where you can lengthen the particles. So you can see here, if I scroll in, that these particles, they have like a velocity. They're like velocity aligned. And so like maybe that's kind of like a shutter speed, but I guess what you're talking about is you want to see like full lines and stuff traced out and drawn with a shutter speed, you know, like if you had like a light or something like that and you're flipping around and people take those crazy pictures. So maybe that's something we could add in the future. We'll see. When is the deadline for the application? The deadline is basically now. It's I guess we're going to review applications as they come in, and especially next week we're going to start reviewing, and then maybe do some interviews and things like that. So you are racing against the clock, basically for the job application that we have open. Somebody says we need or actually Jeremiah, one of our UI dev, he says we need a bot that answers the animated questions. Yes, we do. So let's see. I'd say a modern GPU is good enough. it's just going to take longer if it's not as good. That is true. The more memory bandwidth you have in your GPU, the better EmberGen is going to perform. Hey Nick, the volcano looks sick. Thank you very much. I think that's about it. Is EmberGen just for flipbooks or also proper UE4 particle simulation? Just flipbooks right now. We do have plans to do a Niagara integration where you can plug in simulation data and animated vector fields and volumes and all kinds of crazy stuff, but it's going to be a while before we get to that. But it is pretty high up on our radar, especially with Epic showing off their new Fluid Sim stuff. They're a long way out too, I believe, but we will get it in soon enough. So it is coming, but like real-time sims, you're really pushing your luck, I think. Maybe we could do like a 2D hybrid or something like that. But full-on 3D, I think that we're still years away from being able to do that in a game engine and have that done. So we're about to go ahead and talk about these particles. Let's go ahead and see this junk. All right, so animated meshes with materials. We're not going to support materials in EmberGen because we are not a renderer that wants to support materials and shaders and all the stuff that comes with that. If you want to do that, go use our partners renderer, Octane, and they will happily sell you a license to their renderer, and then you can use EmberGen directly with that. Especially once EmberGen is integrated, which EmberGen Effects, Otoy's version of EmberGen, was just released yesterday. Still the exact same standalone that we have here. It's just you use your Otoy login, and if you are an Otoy subscriber, you get the beta version of EmberGen for free until we have the integrated version done. Otherwise, you can buy EmberGen from our website. Let's see. Okay, I think that's it. Yeah, okay. One last thing. I'll have to shut this down. NVIDIA did it. NVIDIA GameWorks ran in UE4. Yes, it did, but you never saw a game use it, did you? It's because it was far, far too expensive to run in real time in a game engine. It was just too much, right? And then at that point, the fidelity of it was quite low, so VFX artists were better off just using flipbooks to get the look that they wanted. Yeah, and so as Andreas Glad said, which he's one of the best VFX artists I can think of for games, he definitely knows what he's talking about there. So, yep, EmberGen does 3D sims, and it will not run alongside a game, at least for the foreseeable future. We'll have baked volumes and things like that, but we'll get there. All right, so crack these knuckles. Let me take a sip of water, and we're going to dive into GPU particles. I'm going to show you how to use them, going to show you how to create stuff with them, and we're going to have a fun time here. I've done 17 minutes of blabbing. 18 minutes, actually. All right, got to sit up. So, to get started with GPU particles, we're going to go ahead and do a new preset here. And so the gist with the GPU particles is that inside of your volume node, you have a rendering mode. Originally, we were going to have particles separate, so we were going to have like a volume node and a particles node or whatever. If you wanted them both, you plug both of those things into rendering in the scene node and things like that. But it was really complicated. It didn't work the way that we wanted it to. So we decided to add it to the volume node. And in that case, the volume node is probably going to get renamed to something like rendering or renderer or something along those lines because it's going to be more of a global rendering node instead of just volumes now that we have GPU particles. So keep that in mind in the future. So if you want to use GPU particles, it's very simple. All you do is you just change your rendering mode from volumetric to particles experimental. You can see that there is a performance hit. And the reason for that performance hit is because particles are not cheap, okay? Our volume is relatively cheap because we're using ray marching and we have, ways to do like checkerboard rendering and things like that so that we're, skipping every other frame for rendering certain parts and things like that. And so we have optimizations. With particles, it's a bit different. You have to be very explicit on the GPU about it. You have to tell it exactly what you want to sort, all that stuff. And if you guys are interested in your statistics for how good your GPU is doing, you can hit Control 4, which actually you can hit Control 1, 2, 3, or 4. And you can see over here we've got all these cool little numbers. You can press those keys again to make them go away. But we can see that our initialization for GPU particles is 7 milliseconds. The simulation of them is 13 milliseconds. And the renderer is something like 28 or like 18 seconds total, because we have the radix presort, then the radix sort, and then our renderer. So we do have some faster modes. So basically, you have your blend type, right? So within this, you can say, I want my oldest particles first. So like up here, these particles are the oldest. And within that, you can see that if we go over it, we do have this like ball of new particles. You cannot see it. They are sorted. And if we go up here and we look under the ball, you'll be able to see that we can see all the old particles first, because that's this particular type of blend mode. And then we have newest first, which is where the newest particles show first. And then the old particles get cold first or whatever. And then we have a actual full sort. So if we look from the bottom, it's sorted. If we look from the top, it's sorted. If we look from any side, it's completely sorted in real time. This is the most expensive option that we have, because it is sorting millions upon millions of particles. If you make your particle pool 20 million and you are sorting 20 million particles, it's going to take a little bit, right? You're going to have a pretty significant frame rate drop just because there's so many particles that you're trying to sort. It's not an easy problem to solve. We did solve it and make it pretty much real time. 30 FPS is technically real time, but this is still pretty damn fast. And so we have that. And then, of course, we have opaque. So if you want to just have a cheaper rendering mode, there are some scenarios where opaque particles might be your go-to. So you do have that option. Opaque particles do have a different shading than translucent, because translucent is using your volume shading, whereas opaque is a little bit more difficult to get that because you don't have your opacity values and all of that stuff. So then we have additive, which of course is a really great thing for, let's see, if we go to our presets and we load up, let's say this this poison shockwave, I believe this uses additive. Actually, it's using translucent first, but we can change it to additive, and you can see how good it gets. So if we do additive, you can see we get these really nice white lines and things like that. Whereas if we do like translucent, the colors are a little bit more blown out. So for this particular type of effect, I probably should have set the default to additive, because then you can see you get like these really cool, like bright white highlights and things like that. And I think it looks a lot better, honestly. So that's kind of your sorting modes. That's the options that you have to display how these GPU particles are rendering. And so it's really cool. And throughout this, we're probably going to create some little shockwaves like this. We'll create a couple of explosions and just mess around and show you how to create all this stuff from scratch. Let me look at some questions real quick. Let's see. How to export particles to Octane. You cannot export these particles to Octane as 3D particles, so like a Limbic or PRT or whatever. You cannot do that yet. I don't know when we're going to have support for that. It is not a simple task, and that's one reason why our GPU particles are still labeled as experimental. But you can comp them. So you can see we've got our image preview here. You could export this as an image sequence, so 4K images or whatever, and then comp that in Octane or whatever. But in that sense, otherwise, there is no way to export GPU particles in a 3D manner. It's just 2D image exports for now, which is great for our games people, because that's all they really export. It's just the flipbooks and stuff. So yeah, so if you're like a compositing artist and all that stuff, and you want to do image exports, that is the only way to get it out of the software for now. So let's see. Can EmberGen use multi-GPU? Not yet. It is something we want to explore in the future, as Jeremiah said. Apply for an Epic Mega Grant and grab a RTX 2070 Super. I am waiting for the 3080 Ti. is what I'm doing here. Yeah, additive is for the real sci-fi stuff, absolutely. I'm particularly interested in how you get that liquidy, stringy look. We are going to go over that. We can go ahead and cover it now, but we'll cover it more later. So basically, inside your emitter, sorry, I say basically too much. Damn. So we have our volume node here, and what you see within this rendering mode, this is really all there is to particles inside of this node. Of course, your lighting settings and all that stuff do apply if you're using volumetric shading for your particles, which we'll get into that too in a little bit. But yeah, so let's go ahead and show off how I did this stringy look so we can show that off. So basically, what we have is we have different spawn modes. So we have regular, which if we just pause this and we step through a couple frames with Z on my keyboard, sorry, I had to burp. What we have is we have just this little ball of particles, and you can see that they're just kind of spawning randomly, and we're stepping through, and it's just doing its thing, right? There's no explicit strings there. So that's just our regular randomized spawn location throughout your emitter shape and all that stuff. Then we have entangled. And so if we do entangled, what entangled is doing is, if we restart this, what it says is, I'm going to draw a path. And so it goes and draws this path with its math or whatever in one frame. And it says, this is the random spline-like path that I want to take. And then I do that again, and I do that again, and I do that again, and I do that again. And it just creates this entangled mess of particles, right? And so within that, this entangled mess of particles goes out, and because they're already clumped together, they have the tendency to stay clumped together due to the way that we're advecting them to the field. And that's how you get this really nice liquidy look, because they're all being pushed out at the same velocity at the same time, and it keeps that really cool liquid-like look. And so that's how you do it. We also have a clustered mode where you can spawn little clusters, which also tends to create a cool liquid-like look. And so if we pause this, you can see it spawning these random little spheres of stuff. And it's really cool because it kind of like randomizes all their locations, and it's like a bunch of like water droplets or whatever slamming into the ground in this particular case. So really cool. So you do have plenty of options. Well, plenty meaning 3. So you do have some options of how you want your particles to spawn. So there's regular, entangled, and this clumped, clustered emission type. So some really cool things. I don't have a preset that uses this clump type, but it does look really cool. It's like a bunch of little it's like a bombardment of little acid bombs or something. So really, really cool stuff. It's really awesome. Yeah, and so somebody says, I'm a compositor. The EXR export covers a lot of stuff. Yes, it does. And so, yes, I do use a GTX 1080, so I'm not even on the RTX series yet. And so I'm just waiting on the 3080 Ti. Wink, wink, NVIDIA, we love you. Give us those cards. I'm waiting for the 3080 Ti's to come out. That is going to be really, really great. So yeah, so these entangled and clustered settings are so fucking awesome, guys. Oh, I love it. Which actually, whenever we first implemented particles in our other mode, it was working fine, and then we implemented the particles and to like take our randomized shapes and stuff like that you can plug in, and then entangled didn't work anymore. And I said, nah, we cannot ship without entangled and stuff like that. And that's one reason why we delayed the release like a week or two. It's because we wanted to get all the other old features that we had when we had our old particle integration. So had to get that in. So it does look really good. Is it possible to have them even more liquidy? Unfortunately not. So I can show you a preset that shows you like as liquid as you can get until we have our stuff. So this right here, like say we've got like this alien blood splatter. So we've got that. You know, we also have a, let's see, like a blood splatter. So here's like a cool little blood splat that I did, which you could use for a flipbook for a game or whatever. Of course, it doesn't have all the cool, intricate highlights and shading and stuff like a blood splatter might, but you could potentially use this as an alpha map for your blood and things like that in a game. And then if you exported a normal map and things like that, maybe you could get a really good blood splatter out of this. But if you're wanting true liquids, we'll have a tool called EmberGen sometime late 2021, early 2022. I know that sounds far away, but it'll be here before you know it. And so we do have plans for a tool called EmberGen, which will simulate all the liquids you want in real time. Hopefully, if we can crack the code to that too. So yeah, will RT cores help in EmberGen? No. We don't use any NVIDIA specific things at this time. In the future, they may help. Right this second, it does not help at all. All right, so going through these particles again, what we can do is I will, actually, I'm going to go back to our default just so that I can kind of show you how the other things work within the particle system. And then we're going to get into diving into how to make a couple of effects from scratch. So it'll be just like a tutorial. I'll show you how to make some shock waves and things like that. And we'll just kind of see where the flow goes kind of thing for that. But it should be really fun, and I hope you stick around for that. So within this, if we go back into the volume node, we want to change this to our particle rendering. We also do have a hybrid experimental where you can do both voxels and particles at the same time. The only problem with that is that the particles are not sorted. So for instance, if I bring up another emitter, and let's say I turn my fuel rate off and all that stuff, and I plug in the same shape, and then I drag this emitter over, let's say I restart it, and I change this to per particle, because it won't work with volumetric shading because there is no volumetric shading for it. Right there, because it needs the smoke from the volume to actually be shaded is what it needs to do to work. So you can see we're hitting the bounds or whatever, but here you can see, which actually this is really weird. Maybe I need to turn my particle rendering off because it looks like it's sorting properly, but it's a lie, I promise. Let's see, turn off that stuff. So yeah, so now we can go into that. Now you can see that the white particles are showing through the volume at all times. And so it does not sort correctly at this time. So be careful whenever you're using hybrid experimental. Also be careful when you're using hybrid experimental because it is prone to crashes. Hence why we named it experimental. So within that, we do have this particles experimental stuff. Really cool things. Let me go ahead and just reset my project again here. And we'll hop back over to particles. And then we'll change this to translucent sorted radix for good looks. Let's see here. Go ahead and open our, I don't want to open our project. Here we go. So emitters. So within this, if you scroll down, actually, well, let's go ahead and talk about this. So inside your emitter, you can emit both particles and volumetric stuff. All of your emitter parameters that you had previously before this update are the same. The differences being that we added some new particles, parameters, settings, and things like that. And so you can see down here, we've got this particle parameters tab. You can collapse it, open it, whatever. And within this, we have a continuous emission. We have a burst emission. So you can increase the amount of particles that you are emitting. If you do reach your particle pool threshold, which I am at this time, if I go to my volume node, I can see that I have maxed out my pool usage. And so I would need to increase my particle pool if I want my particles to live longer. So I increased it to 11 million particles here. You can see that it is significantly slower because it is trying to sort all these particles in real time, do everything that it needs to do. But you can see that you have a higher fidelity, higher resolution, all that stuff. The more particles you add, it fills in all the gaps and you get a more wispy look. So the more particles you have, the better the higher likelihood it is that these particles will replace your volumetric workflow if you're looking for something highly detailed and takes less computation and all that stuff than a really high resolution voxel volume. So you can see that we do have some really, really good details in here. Of course, it is kind of grainy because that is the nature of particles. Somebody asked me, why is it so grainy? Well, because that's what particles are. They're just by nature grainy because they're little points in space. And so we have that. And then, of course, one thing that we can kind of shift over to is the draw mode for these, or the render type for the particles. So we have camera aligned, which just means that as you rotate the particles, billboard will rotate to follow the camera. Then we also have velocity aligned, which you can see the sim did change a little bit. And so we can increase this and say increase our scale. And now you can see that our particles are velocity aligned and they're kind of stretched out and blurred. And so that gives you even higher fidelity and things like that. In certain cases, you have less of a gritty look, more of a coherent, wispy look in some cases for velocity aligned. Then you have a blur type, so you can do symmetric or asymmetric, reverse asymmetric. And that just determines like what kind of blurring you want to use on your particle spray as it's stretched out. And so, yeah. And so within this, you do have a maxed out particle pool because I am going crazy right now with our spawn rate. So I'm going to go ahead and lower this back down so that we can get some better frame rates, just for the sake of this demo. But you can see all of the volumes, or what do you call it? Velocity stretched particles being activated here. And so it is really nice. It's a nice thing to use. And then, of course, with particles comes extra controls for lifetime, min and maximum sizes. So you can have small particles. Like right now, most of these particles are roughly the same size, but you can increase it and decrease it. So some particles in this case now are really small, some are really big. And so you can really see that here, some of the really big particles, which that does lower your frame rate because bigger particles is harder to sort and it's more work for the GPU with overdraw and all that stuff. But you can change like your minimum and maximum sizes. We do have a min and a max lifetime. So, we can make these particles only last just for a bit. So let's go ahead and restart this sim. And the maximum these particles will last is 0.835 seconds. You can see that now we don't have particles that last as long. And so now that we've got our lifetime and our sizes randomized and stuff like that, you can do size over life attenuation, which just means like if it's 100%, then all of the particles are going to eventually fade out to a size of 0. And then depending on what your size over life is, it'll kind of randomize that for each random particle. And then we have a tightness parameter, which basically chooses how closely do you want these particles to follow the volume. Since these are velocity aligned, it is hard to see, and if we change the tightness, it just doesn't really work at all, or at least on lower values. But what it's doing is it's just saying, how closely do I want to follow my velocity grid? Because if we click show velocity here, you can see all these little arrows, and that's what the particles are following. So if we increase our tightness, it's going to choose how closely these particles follow that vector field or flow field or whatever you want to call it. Then we have tightness attenuation over life, which basically says after a certain period of time, which it might be better to show that particular parameter on a preset here. So let's look for, maybe we'll do, where's that? Maybe my realistic aerial explosion. Let's hide my stuff here. So here we go. We've got an explosion showing off these particles. And so if we wanted to attenuate our tightness over time, I think that this would be a good example. And so let's go ahead and attenuate it over time. Then you can see that what it does is the particles, they carry on, which not all of them are because I have two separate emitters. But if, say, we show just this emitter with just this little stringy burst that I made, the particles eventually just say, you know what, I'm going to forget the velocity field and I'm just going to continue on in the way that I was going, and then I'll accept my particle gravity and all that stuff. So in your simulation node, there are a couple of particle physics things. What you can do is you can say, hey, I want my particles to hit the bounds and then stop, right? So if we show our bounds here, maybe our particles will hit it. Yeah, so you can see on this side right here, we do have some particles that hit the bounds and collide with it. Or you can say ignore, which means that the particles will just continue on outside of the bounds. They don't care. And at that point, they just can't be simulated anyway. They'll just kind of fall down with their typical stuff. But what we have here is we've got this going straight through, and like I said, it's carrying on. And so we do have a gravity intensity. So if I increase that gravity intensity, you can see that those particles will fall faster. So in that case, if you have explosions and stuff like that, you could have like little debris that are going up into the air and then falling back down and things like that. So you can increase your gravity intensity. And then with our velocity dampening, it dampens the velocity and just makes the particles slow over time. So it's kind of like a drag through the air type setting. So you are free to edit that as well. Then if you don't want particles to exit the bounds, you can change your bound type to kill. And then what we have is a adaptive substep advection. I have not tried this, but I think what it does is it makes your particles simulate a little bit better so that there's not gaps in between them if you have a moving emitter. If Gil is in the chat, he can let me know the exact thing, but it says if active, the advection will be more accurate and have a higher load on the GPU, especially efficient on high velocity simulations. Yeah, so if you have a high velocity simulation and you want your particles to be more accurate, you can check that box. And then improve the advection quality by using tricubic interpolation instead of trilinear. Yeah, so we have some options for you. If your particles just aren't spawning right or they're too high velocity, you can check those two boxes and get better results. And then we have our advection chaos, which this is kind of a cool setting. Essentially what it does is what you're doing is you are advecting all of these particles, right? And so if we unpause it here, or sorry, if we set that back to 0, you can see that these particles, they pretty much straight on follow the flow field as we would expect it to. And so especially here. So what we'll do is we'll turn off our tightness attenuation over life so that we can see what it would do in normal circumstances. And if we go back to our simulation, this advection chaos just adds in kind of like some random noise into it to help break up that motion. And it kind of like switches between like tight and not tight, tight, not tight, so that your particles seem a little bit more alive rather than following the explicit field. And so that's a good way to get some extra movement within your particles if you want that option. And if we read the tooltip, it says defines how strictly the velocity field will be followed. Increasing the chaos can break the regular front lines that may appear following the velocity field. And so front lines could mean say this. So you have these strings, which in this case I am using entangled, but say you're using some other mode like a regular spawn mode and you don't want those lines and stuff, you can do this advection chaos. It'll make sure that the particles are more spread out and random versus following an explicit line or trail. So pretty cool stuff. We can hop back over into the emitter and maybe bring this emitter back. And so what we've got is we went over our min size attenuation, tightness over life, sharpness just shows how sharp the particles are or aren't. So if they're not sharp, then there's a little bit more translucency in this case. And as we sharpen it, you can see that the edges, well, of course, they get sharper. So if we scroll in a lot, you can see that it's very sharp and then it's blurred, right? So you have the ability to change the sharpness of your particles. And then with timing randomness, I don't know in particular what that is, but I think it randomly, like, it kind of changes how the timing works. So what we'll do is we'll go back and disable that. And so what we can do is we can just do timing randomness. So unfortunately, I don't know what this is. Okay, yeah. So in this case, we don't have a lot of particles spawning on this little beam, but it looks like if we randomize our timing, then it kind of picks and chooses different points, which Gil, if he's on here, he can explain what do you call it? He can explain this a little bit better. I'm not sure exactly what this one is. I've tried to play with it, but I can't really decipher it. But I think it just randomizes the timing of the spawning. So say you're spawning 5 million particles, it might spawn, say, 1 million, and then 500,000, and then 200,000 or whatever, and then 5 million or whatever, right? It just randomly spawns the particles at kind of different intervals rather than a constant rate. And so I think that might be what it is. And so that gives you a little bit more chaotic looks and things like that. Of course, then we have our particles renderer, which is camera aligned, and our velocity. Our default probably should get changed to velocity because velocity typically looks better in most cases. And of course we have our blur type, which if we pause this and we go through it, maybe we can see it on like some of these sparks or something. So we'll go into here. We'll change our blur type. So we'll say asymmetric. So you can see here that on the leading edge, it's not as blurred, but then on the back edge, it's blurred, like motion blur. And then for reverse asymmetric, it's the opposite. So the front edge is blurred and the back side isn't. And then I typically just do symmetric so that it's even. But if you want more of a motion blur look, you can do asymmetric. And of course, you can change like your particle scales, your velocity limits, things like that. And so you do have the ability to change your particle scale, and asymmetric probably will look best for this kind of stuff. And you can see that it is really hairy in the front, which is pretty cool for some things. You know, that might be something that you want to do. Maybe you got like a fiery hairball looking thing. And so that might be something that you want. Another thing that you can do, of course, with anything with EmberGen is you can animate your parameters. So for instance, let's say that on the first frames, let's say up to, I don't know, maybe frame 14, which is this current frame, we want it to be a velocity scale of 200, and then we quickly want it to fade to a average value of, say, 90, right? And so what that'll do is at the very beginning, your particles will be really hairy and long and have a high velocity, but then they quickly fade off. And so you can even reduce that more. And so then you can see here, boom, really hairy, really high velocity, and then you move that scale down through an animation, and boom, you got some really cool stuff. And so just some more things to add extra variation, switch up our presets, switch up your own simulations, that kind of stuff. You can animate any of these parameters over their life. So, you know, you could even animate, you know, the shading type or the emission type or whatever. So what you can do is you can say, you know, I want my very first thing to be entangled. And then after that, I want it to be clustered. And so what you've got is, boom, you've got this, it's entangled, and then boom, suddenly it does some clusters. And if we increase our animation duration, or sorry, our emission duration, which actually it's not going to work because I'm using particles for this, maybe what we'll do is I'll just quickly plug in this shape. And so then you can see at the beginning up here, I don't know why it's all the way up here, but it is. So we've got entangled, and then it moves to the clustered mode. So you can animate all of these different settings to your liking. Well, let me go ahead and open up a new preset since I kind of messed this one up. Let's do the spiderweb venom one. This one is really funky. It's a pretty crazy, preset. And so while we're looking at this, I'll go ahead and answer a couple more questions because I saw some interesting things pop up. So we'll take this second. I answered the, is it possible to make it more liquidy? The answer was no to that. Really, EmberGen? Yes. I'm going to try it here. Nick, can we use the GPU if we have multiple, can we choose the GPU EmberGen is using if we have multiple GPUs? Yes, especially if you have like NVIDIA. You can go into the NVIDIA control panel and tell any program what card you want to use. And just for the sake of EmberGen, you might want to do that so that it doesn't get confused when choosing a graphics card. Like Bifrost, we don't want to go as far as Bifrost does. They do like snow and cloth and all the other stuff too. We really just want to do like explosions and liquids and destruction, and that's about it. And so maybe we'll do more in the future, but for now that's all we're really focused on. Yeah, please don't ask for EmberGen to be open source. We're not going to make it open source, at least not in my lifetime. At this time, unless somebody gives me like $100 million, maybe Epic or something. But yeah, it's not going to be open source. We worked way too hard to just release this out there for other people to clone and make their own products off of. So yeah, the amount of particles allocated will be available to be spawned. Yes, so that was in relation to the particle pool question that we had. And then let's see, colorize particles by age. Yes, you can color them by age. I will be showing that off here soon whenever we get into how to shade your particles, and that's going to be the real fun section of this stream. I purchased a 1-year pro license, but open source yeah, okay, not going to answer any more open source questions. You can't color particles by velocity yet, but we do want that to be an option. hopefully here soon. And then let's see. Does EmberGen have space warps or gravity or speed forces to only influence some parts of the simulation? Yes. What you can do, just for a quick tip here, if you spawn a random emitter, and let's just make our smoke rate and stuff like that 0, but what we'll do is we will have an explicit force, let's say a line force, and then we want it to have a twist or something like that. If we show our velocity here, which this is going to lag like crazy, I bet, so let's not do that. But what we can do is we will have a shape up here, we'll do a sphere, and we can see this primitive by doing show emitter. So we see this, and so this right here is going to be our mask for this force. We're not emitting anything else, we literally just have a force. And so now if we do this, and we make our twist strength, say, I don't know, 25, just so that we ensure that it works, and we turn off this, say the continuous emission, and the show emitter, you can see that now whenever the particles get to that, they twist around only in that specific spot. And so what you could do is, like, you can have this shape right here animating, whatever, and you can see that it is affecting the simulation. And so it's basically a masked velocity field. And so yes, you can create that. You can compose forces and have like a random noise field or whatever you want. So yes, that is how you have special shapes as a force field in particular. Let's see. So if I were to use these particles for an explosion, could I have fluid explosion, flipbook that, and then take that same sim and do particles with it, kind of layer them in UE4? I mean, you can really do whatever you want. I mean, there's nothing stopping you from using both, a rendered particle version as a flipbook, and then, or like a voxel version, and then doing a particle version and overlaying them or whatever. You're free to do whatever you want. Feel free to experiment. Let's see. EmberGen can work with AMD cards. Yes, it should work. And so we have had a problem in like the past where like meshes and stuff like that won't render. Hopefully we fixed it. I don't know if we did, but yes, AMD cards do work. So back to this. Let's go ahead and dive more into the tutorial real quick. All right, so I am ready to go back into the tutorial. So what we'll do is we're going to go ahead and create a new preset here, and we're going to make a burst. So we'll make like an explosion, and then we'll go over all the particle colors and how all those particle colors work. So what we'll do is we'll go to our volume node. We'll change this to particles experimental. We will do translucent sorted. Then we're going to go into our simulation, and let's increase these bounds to like 160 by 160 by 160. And so for the typical simulation, that seems small, but for particles, that is quite big because particles are so much more detailed. And so what we'll do is we will add a force to this. We will increase our scale. Let's go ahead and increase our amplitude to say something like 50. And then boom, we've got this right here. And we can increase our pressure too. And then we've got these particles that are just blowing up. And what we'll do is we'll make sure that we, if we turn off our emission activity, yes, that does work. So we're going to animate this. We're going to put a frame down that says that the frame is on. And then somewhere, which that is, what frame is that? I don't know. It doesn't tell me. It should tell me. Okay, it's frame 12. Okay, yeah, so on frame 12, we have a thing that just tells us to go off. Now we have this cool little burst. And what we're going to do is we want to spawn more particles. Give me more. So I'll also turn on burst emission so that we get some extras. We could turn this up so we could do 10 million particles in total. Let's see, is that 10 million? I wish we had commas inside of our thing here. Yeah, so boom, there we go. There's a cool burst of an emission. Let's see how many particles it says. It's only doing 2 million. So maybe we could boost this up to maybe like 25 million. Which actually, it looks like the highest you can go is 12.5 million per second. So yeah, so there we go. There's more particles. And then in this case, I want to do velocity aligned, so we get more of a volume fill for this particular puff explosion thing here. And so we've got that. I'm going to go into my scene. I'm going to just remove my sky. So I'm going to do a uniform color. We're going to go to like a low gray, and then I'm going to remove my other thing. So now we've got this big aerial explosion looking thing. So what we can do if we want to change things around is we can make our forces a little bit bigger. So our noise force field, you can see that I'll push particles in certain directions. We can also animate our speed so that the explosion is a little bit different each time. And we can also increase like our octave so that our noise is a little bit more random. And so cool, we've got this cool little explosion. And of course, if you want more pressure or whatever, we can go into that inside the emitter here, and we can increase our pressure if we wanted it to expand faster or whatever, but I'm going to keep it kind of low so that we stay within our bounds like we want. And so now for coloring. So this right here is a pretty good step into how you can color particles. So the first mode and the default is volumetric shading. So if we pause this and we go to our volume and we change it back to volumetric, you can see that our volume, our smoke, our voxels, all that stuff is in the exact same spots as our, what do you call it? Sorry, complete brain fart. Let me start over. So if we change it from particles, or two particles, you can see our particles are here. If we change it to volumetric, our voxels and volume is in the same exact spot. And then we are just using this volume data to shade the particles. So for instance, if we went in and say we adjusted the fire color through a gradient, so let's do a color gradient, we'll do temperature, and we'll bring this and make it blue or whatever, and let's make it like a hot white or something up here. I might want to switch those around. So something like this, right? And then we switch this back to our particles. Our particle fire will then be blue, right? And so what if we say, make this go on a little bit longer, we see what our smoke looks like here. We can change, say, our emission contribution, which actually it doesn't. Oh yeah, so it does work. So you can do like your scattering. You can change, your fire intensity to make your fire brighter, more crazy, more sci-fi, whatever. And then of course, on the actual smoke, so let's let that die out. And so over here, we've got our smoke. So on that, you can change like your mid-range shadows, which is kind of hard to see on the stream, but it is changing. We've got like ambient shadowing, so you can, really darken that up. You can change your extinction shadowing. And of course, if we go to our volume, we can see that we're changing all those exact things. So it's taking all this shadow data, all that stuff from your volume and just bloop, plopping it on your particles. And so here we go. Boom, holy crap. Huge burst. And so you've got this huge emissive burst of particles, and then voila, right? So that's the essence of volume shading, and the extent to which you can do things is really what you can just do with our basic gradients for this. So of course we can plug in a custom gradient into our smoke color as well. So let's just do some crazy colors. We'll do like red, and we'll do blue, or say green, and yeah, we'll just keep it at that for now. So you can see that the smoke color is affecting it. So then we've got some really green stuff, and we've got some initial reds and stuff like that in the smoke color. And so all that's being blended in and multiplied, and you get these crazy little colors. So with that said, what we've got is we have that, and that's basically the end of volumetric shading. You don't have too many extra controls. Like let's say that we wanted to make our simulation just basic so that it's not combustion based. Now you can see we have, let me increase my light, right? So you can increase your light intensity so that the particles are brighter in this case. You can go to your volume node, and you can also change like your display scale and things like that if you want to. And then on opaque, which I think this is specific to opaque only, you can see that we do have these opaque particles. Shading is a bit different. You can change your lighting display scale. with opaque and specific, and then the overall display scale as well. So if you want like some thinner stuff or whatever, you can do that. Then we also have super sampling, so that you can, which is kind of weird and funky whenever you change this, whenever it's paused. Basically, just chooses how smooth you want your opaque particles to be. So you do have super sampling, and that's kind of the extent of that. So we're going to go back to our translucent, and I'm going to show you how to do some really crazy things with particle coloring and per particle colors. And I think that this is really where our particle system shines, and where you can create some truly amazing stuff. So what we'll do is we're going to change our shading type in the emitter. And so the cool thing is, is that whenever you emit particles from an emitter, it's per emitter. So I'll show you what I mean by that. So if we do per particle shading, you can see that it's not going to be just really bright white. And what we can do is we can bring in another emitter over here, or bring in a separate shape. Let's see. We can see it over here, and let's go ahead and change this, which it was, I don't know if you saw it, but it was like a really small green blurb. We'll change this, we'll do per particle as well. And now you can see that we've got this white burst down there as well. And so then, if we go to our initial color, and let's make it like something that we'll definitely see, say red. So now you've got two different emitters and two different particle color types. So you've got a red particle emitter, you've got a white particle emitter, and you're able to change that. And so then, like say for the red, let's make it go back to white, but then we can change those in particular as the particles go over their life. So under color over life, what we'll do is we will change this, and let's do, like say green, and then, blue, or just whatever, just so that we can see it. And we'll do like red, and so that we can see these particles changing over their lifetime. And so then you can see here that at first it is red particles. Now it's switching to like purple, and we can kind of switch this around, maybe make it a little bit faster here. So we got this. So first they're going to be green now because it starts from left to right, and it's switching to red and orange and purple and blue. And if I hide that big white emitter, you will see here, you can see the particles changing color over their life. And so the particles at the start are going to keep their same color that they started off with. And then you get this cool gradient effect. And so, of course, as we change the color gradient, let's see here, you will see that gradient change in real time. So now you've got this really cool color gradient that allows you to mix it up and change how you're wanting to display your particles. And then in this case, you'll say, well, what if I want my particles to be bright? Like now they're not really bright anymore. There's two options that you have. You can do the additive mode, which even in additive, it's not going to be super bright. So what you can do is in the emitter, you go over here and you can boost your color boost, right? So you boost this color boost value, and you can see that now we've got our additive particles going on. If we go back to our translucent, you can see that we've got better sorted particles, and they've got some pretty crazy coloring on them as well, really bloomed and kind of blown out colors here. But yeah, so you can boost your colors if that's what you want. So really easy thing to do. That's how you get some better coloring there for, what do you call it? Lit up particles. There we go. Particles that seem like they're bright instead of just like a translucent shadowed look. Of course, you can use the shadowing from the volume in this case. And so, of course, if we look at our volume here, let's see, does this actually work? If I go to volumetric, yeah, so we are emitting a volume here, and this is the shadow data that we're pulling from essentially. So we go back to our particles, and so inside of our emitter, we have this shadow intensity, and that's what gives us our shadowing intensity. So you can have no shadows or whatever. And so since we're not using the volume, we have to use that volume data. So you do want to make sure that you are emitting smoke and things like that, because if your smoke isn't being emitted in the emitter in the voxel mode, you can see that now all of our shadow data just disappeared. And if I increase that smoke rate, our shadow data comes back. So just something to keep in mind whenever you're working with these particle colors and things like that. So let's see. Let me answer some questions real quick. Looks like some of the stuff is getting done. So the export options you just showed to me, image parameters. Yeah, so if you want to know how to like export images, we have a tutorial on that called How to Export Flipbooks. And it's the same exact workflow for image sequences. I'd love to see you take this into UE4 next, maybe in a future stream. In this one, I'm only just going to show this stuff off, but I do have a stream that showed how to get stuff from EmberGen into Unreal Engine 4. So you can watch that, apply the same exact concepts, and get this in as a flipbook. Let's see, with the new UE5, do you think that's going to improve or change the evolution of EmberGen in any particular way? Probably not. I mean, I don't see why it would change really anything. It doesn't add anything extra other than, say, Niagara, which they're doing some of their own fluid simulation stuff. And we do hope to incorporate directly into Niagara, so we'll see. Can you have multicolored volumes as well? Yes, if you use the, in your simulation, you can use colored smoke, but it is very limited. You can't have crazy changing colors like this to my knowledge. Maybe you can, but it's difficult. You really just have like one bursting emitter and then you can blend those colors. So yeah, definitely something that you can do in that case. We do have a preset that you can look at for that real quick. I'll show that off. It is colored smoke. So boom, here you go. There's colored smoke. That shows how you do it. Here's all the different emitters for it. It's 003 colored smoke, and you can go through that and look through it and see how it's done. And the secret to it is having colored smoke as the simulation mode. So what we'll do is we're going to go back to these GPU particles. Let me do my realistic aerial explosion again. Actually, I'll do my planet, because I think this is definitely my favorite preset that we have now. Actually, I'll do ropey explosion because it's a bit weird. We have these ropes and stuff that come off of it and kind of explode. So within this, like let's say that we wanted to change our ropey particles and things like that here. And of course, if you don't know, the way that this is emitting these strings and things like that is we have this shape particles node. And so what it does is if we show our shape here, it's just emitting these really bright particles for some reason. And so those particles are what emit the other particles. It's like particle-ception. And that's how you emit those, whatever, the strings of particles. Well, not the strings because that's through entangled, but the lines of particles. So yeah, so within that, some really cool stuff here. And so one other thing is somebody said, how do you export VDB for Octane? Go on our YouTube channel. There's an EmberGen tutorial playlist. And I think it's tutorial number 4. You can type EmberGen export VDB or something like that in YouTube, or look on our channel. There's a whole tutorial on how to export stuff. Once you get into Octane, that's kind of up to you to learn, or Octane to teach you how to do it. We're not going to teach it ourselves in particular because we have EmberGen to teach. But yeah, so I'm sure there's tutorials out there for importing volumes into Octane and things like that. And at that point, you're kind of on your own once you export it from EmberGen, at least on our side. So yeah, so we've got this. You've got this cool little stringy burst. And I think that somebody asked previously, which I don't think I answered the question. Somebody said, how do you keep these to be lines? The essential part of it is that if you have your velocity channels affecting your stuff, so like let's say that I do have like noise in my sim or whatever, you can see that now these lines kind of get broken up because I just added noise to the whole simulation. And so the secret to keeping those lines is to really not have a force act upon them. But if a force is acting upon them, those lines are going to break up just inherently. There's no way to really keep them together because it's not like a chain. It's really just a bunch of individual particles that make it look like a line. So with that said, what we can do is I will show you some of the extra crazy stuff here. So what we'll do is we'll just work off of this basic explosion here. I do believe this is using our volumetric shading. And one key point about volumetric shading that I'll show off that I forgot is embers chance. So you can see that with no embers, well, there are no embers. And this right here was a genius thing that we implemented. If you want embers, instead of having a separate emitter to do the embers, you just increase your embers chance. You can see here that now they're they're completely white and not fading because our fade rate is down to 0. If we max out our fade rate, those embers fade quicker on like a black body spectrum. And so of course, the embers chance basically says, I know that you have smoke particles, right? I know what particles are smoke. What is the percentage that me, a smoke particle, is going to turn into an ember? What's the percentage chance that I got hot enough to do that? And so within that, you have your embers chance. And so, keeping it at something really low, like, 0.833 or something is probably in your best interest. And of course, like you could say, maybe I don't want embers at the start, right? So you could animate this value. We can say embers chance 0. Maybe up to say frame 6 or something. And then by the time we get to the end, we have a high embers chance. And so boom, no embers. And then suddenly you have embers, right? So you can animate all these parameters. And then of course, if you want them to last longer, you can change the fading rate and they will live longer. So yeah, so that's how you have embers chance. Really cool stuff. And of course it applies to your color gradients. So if we make this color gradient here and we make this say blue, and now if we look at our embers will fade to blue. So actually it's not using black body in this case, it's using this this color gradient because that's what our fire is using. So it does use the same gradient as your fire. So you can have blue embers, which if we go to the project over here, I think it's called Space Explosion. Let's see if I made it. Oh, Sci-Fi Explosion, which this was pretty cool. You can see that we have some blue embers. And so yeah, so within those blue embers, it's pulling off this blue color gradient, and it's really cool. So yeah, so that's the embers chance. That's how ember chance works. It's really, really awesome. Helps you get extra detail and things like that without having to add a separate emitter and fiddle around with all that shit. So really, really cool. It's a great thing. All right, down to the nitty gritty details of particle coloring over life. I already showed you a little bit with the initial color and how you can map things over life, but the per particle settings are more advanced than that. So we'll stick with this one. We'll do per particle. Let's make sure that our opacity is boosted. So on some presets, you'll find this. If you change it to per particle, it just might not work. It just might not look like it's doing anything. And to change that, you need to make sure that your opacity is, say, 100 or some variable in between or whatever. You just want to make sure that you have a higher opacity than what it had set, which this actually looks really, really cool. But what we can do is we can make it cooler if we end up using some coloring over life. So what we can do is, of course, you can have your initial random color, like I said previously, but we want to make this white so that what we'll do is we'll change our initial per particle stuff. So of course you can have it, random per particle. And in this case, it's just going to base it off of this initial color. But if you expose your initial color to the graph, what we'll do is we'll make a crazy gradient again. We'll do some red, we'll do some like pink, and we'll do some super bright neon green. And let's kind of, merge these settings up like right here. So we'll do something like this so that they're really explicit colors. And now let's go ahead and set this over to the end. Maybe we'll drag this out. So now we've got some pretty distinct colors to choose from. So right now, it's just saying, hey, I'm going to choose randomly for each particle, just some random color on this color line right here. So, any position on this linear gradient of colors, I'm just going to choose a random one. And so now you can see we've got this big conglomeration, just puke vomit of colors here. And of course, if we add in blue, you'll start to see some blues somewhere in there. And so, yeah, so you've got just this huge, crazy color spectrum of colors. But what if you want it to be a little bit more of controlled chaos, but still have those randomized colors? So you can do random position based. So what this does is if we sim it and pause it, you can see that now we are emitting the emission is the same, but the colors that are being emitted are specific to a noise texture that we have. And so we can change this noise frequency, which unfortunately we can't do while it's paused. I wish we could, but we can't. So you can see that if I make this noise texture bigger, obviously there's less stuff here. But you can do like a noise speed. So say we emit for longer here, you can see that the particles are going to get pink and all that other stuff. And it gets pretty crazy and hectic in the middle there. But we do have that for you. And so it's probably best to keep the particles at a lower noise frequency so that you do get that randomized stuff there. And then we also have cycle with time, which just says, what I'm going to do is I'm going to go from the left side of the gradient all the way to the right in some amount of time. And I think at the end it just stops. And so in this case it's 1 second, but we can do say 0.25. So boom, it's going to be green, then it's going to be pink, then it's going to be red. And so we can see inside there, we do have some red particles that are kind of coming out of this. And if we say remove our noise there, and maybe remove our, our pressure. So let's say we make pressure 0. Now you can see that we've got this change in particles. Actually, it looks like it's just cycling through. So I think it just goes from the left all the way to the right. Once it gets to the right, it just starts over again. And you can see that cycling through with time. So what we can do is we can bring this back up to like 150, and we plug our noise back in and get back the thing that we had. So that's how you kind of do these special color gradients. And we also want to have a thing where we were discussing it earlier this morning, where we want to have like 2D color gradients. So like right now our color gradients are just 1D. It looks 2D, but it's really just one line of pixels, and we read from that, and that's our gradient. But what if you could do a 2D gradient where you can have a lot of these gradients stacked on top of each other, and then edit that, just edit it, right? Just have different blur settings and things like that, and blur together all these gradients and have like a cool little gradient builder, and then lerp through that gradient over time so that you can get more complex color variations and magic effects and things like that, rather than being stuck to just one harsh singular color gradient. So we do have plans to do that. Of course, if you go back into this emitter, so we had cycle with time, and then we have ping pong with time, which starts from the right, and then it goes to the left side of the gradient, and then it just says, okay, I'm pinging you back to the right. So it goes from the right to the left, to the right, to the left, to the right, to the left, so on and so forth. And it just does that and ping pongs back and forth for eternity. And so like if we do like a really fast ping pong here, so like 0.83, boom, you can see it ping ponging really quickly. So if we step through this right here, you can see red, there's some pink, there's some green, and it looks like more pink and stuff is showing through, so on and so forth. So that's what ping pong with time does. And that is kind of the gist of your random per particle coloring on your initial color. Then of course you can do some of this stuff with your other coloring. So you can multiply other colors. So whenever you do your color over life, so your initial color is like your base color. Then whenever you have your color over life, what that's doing is that's going to essentially just say like, hey, I'm going to just multiply against my initial color. So you got to keep that in mind when you're doing this. And I will show you an example of where that really matters. So you can see at first it's dark and it's just not bright because we've got these really dark colors, and which is really hard to see. I hope it brightens up soon. Maybe we'll do like a quick white or whatever. So we'll do something like this. So at first it was dark, and then it lightens up and turns into white. So you can do that, or you can do it the opposite way, where at first it's really bright, and then the particles just fade out, right? And so who knows? Maybe you want to do something like that. So you have that option to multiply those colors on top. Of course, you can multiply like a crazy color, like say yellow, against everything, and then you can see everything is going to get this yellow tinge with the color over life. And so that allows you to do some extra stuff. Sorry, I read a comment here. Let me just see some of the comments real quick while we look at this. I'll open up the next preset to show of why you might want to multiply things. I think that it's, oh no, it's the ignition gradient one. I think that the planet explosion uses it too, but I'm going to open up the ignition gradient and then I'll answer some questions. Yeah, so we have this. So this, this is a really cool example of what you can do with these color gradients without having to use your volumetric shading or having to, you know, do good combustion or whatever. So we can like increase our shadowing intensity and stuff to get a more realistic thing. So maybe we could even boost this like, oh, no, you can't boost it higher than 500. Anyway, so really cool that it just kind of like, boom, emits some smoke and then just explodes into this really cool explosion. Some of the questions, EmberGen going to have its own rigid bodies? Most likely not. Let's see, embers are a nice touch. Thank you very much. Let's see, any chance of having a texture on the particles to avoid the roundness bit? Probably. I do want us to have like a texture or a read from an atlas or something like that so that you can have like debris and all that other stuff and like particle rotation and extra stuff. That's some extras that we hope to add on to GPU particles eventually. Export your gradient to match things in Unreal. I'm sure we can probably do that. Actually, I had a tool idea for a special color gradient idea for color gradients and gradient mapping in Unreal, and like view your textures in the editor or whatever. So maybe we'll add that whole workflow to EmberGen. Let's see, being able to import textures, choose things would be really cool. Yep. Let's see, Nick, you're a magic. Thanks so much for the great software and pleasant attitude. Thank you. And then the one I laughed at, breathtaking. Can you create a really fast fart simulation? It'd be really professional. I love you. All right. Yeah, I could do a fart simulation. Why not, right? Hey, come on, it's EmberGen. We can fart all day. I'd love to see this get brought into Unreal and have it run in real time in their game engine. We would love it too, but you can see how intense this is. Not anytime soon, but we could probably do like animated vector fields and you can advect their GPU particles to get similar things. So definitely on the plans. 2D ramp, like a UV map. Yeah, something like that. Sorry, was away due to an emergency. Hope nothing bad happened. And then said didn't catch the stream for a bit. Let's see. Is there a list somewhere that shows which nodes can be used as a curve? Seems like many new ones added. Basically, the only thing is with these gradients, if it is a color, it most likely can have a gradient. The only things that work with gradients right now, for now, are... Where's it at? It's not going to show because I'm using the wrong simulation mode. But basically, fire color, smoke color, and then inside of your emitter, you have your color over life and your initial color. Those are the only things that use gradients. Okay, into the fart simulation, like people want for whatever reason. Don't make me do this. Okay, so what we'll do is, let's go ahead and just clean up this node graph real quick. We'll delete those two things. We can just make a variation on this. So what we'll do is we can just make this beginning green, right? Like a deep toxic green. Actually, looks like it is the opposite direction here. There we go. Toxic fart. Okay, here we go. Let's see, we'll do like a line force and we will lower this force right here to maybe 20. And then inside of our emitter burst, we don't want this randomized pressure. Oh, come on, 0. Okay, there we go. So now we have that. And let's go ahead and maybe just delete our noise. And in this case, we have our force line. We're gonna do maybe 15. Okay, and so we have that. And so then we can also move this color gradient to last longer so that it's more fart worthy, I guess. I don't know. And so then we have that. Yeah, so that's kind of like a fart. I guess we can just delete these fiery colors as well. And so there you go. It's kind of like a thing, and you probably want it to not last as long, right? So we can do like 0.1 second, or let's do like 0.1 and 0.3, so it's just a quick one. There you go. It's kind of farty, I guess. I don't know why you made me do this, but well, I chose to do it because it was funny. But Anyway, there you go. There's my best attempt at it. And of course, you have your volume, of course, and you can just change this from simulation to let's see, basic. We want to make sure that we turn our fire color off, emission contribution off, and then just make our smoke like a green color. And there you go. There's your fart. Anyway, okay, I'm done with this. Okay, texture emission based. You know what? I don't know if that actually works, but we can test it real quick. Let me go to let me just go to a random thing here. And what we'll do is, as our shape, we will do a, oh no, there is no bitmap right now. Okay, yeah, so I can't do as a texture because we don't have that as an option. But there used to be a thing to where you could, what do you call it? There used to be a thing where you could do a bitmap in the alpha, but we removed it because we need to add it. But yeah, so there's that. Let's see. So let's see. People are saying, is there a list that shows which nodes can be used? Oh yeah, so I answered that. Might be too techy question, but what language is EmberGen written in? So we use a language called Odin. It's a language that one of our friends and soon to be full-time employees, it's a language that he wrote, and we decided to use it because it's really performant. And so that's what it's built on. And then we use HLSL for our shaders. So OpenGL is what we're in on the back end here. So let's open up our cool little manual here and answer a couple more questions. Yeah, glad went ahead and said it's written in Odin, which is true. Ice cream is cold. Yes, ice cream is cold. Are you a bot? Let's be honest, that was fast and professional simulation. All right, so there we go. So within that, that is basically it with the particles. What we can do is we can make like a simulation like this and a shockwave and maybe a quick explosion from scratch, and then we'll call it a day. So we'll start from a new preset on each one of them, just so that you can follow along. All right, so if we're going to make, say, an explosion, we will do particles experimental, change this to translucent radix. In this case, we're just going to use our basic volume shader for this, I think. So we'll go ahead into our emitter. We want to do, say, 150 for our pressure rate. And in our simulation, we want to change our bounds to maybe 192 to 192, 192. So let's go ahead and apply that. And then, of course, we want to only emit a specific burst. So we'll do on, and then we'll do, say, off really quickly. So something like that. And of course, we want to max out our rate. So I think it's like 12 million or something like that is our maximum. Which that's kind of weird that it just bugs out like that. So maybe we'll just stick with 5 million for now. We can boost out our initial burst as well. And then we want to add in a force. And so we will add this in, say like 7. We'll do an amplitude of, say, 150, which really helps us blow these particles out of the water. And then inside of our simulation, inside of our volume, let's see how many particles we're reaching. And let's kind of increase our pool size. And so we'll do like 10 million as our particle emission rate. And so then we've got that. And let's go ahead and show our bounds. And let's move this explosion up into the center so that it kind of blows outwards like we want it to. And then, of course, if you want to change your noise, you can change your noise seed and your octaves and things like that to get a different shape for your explosion. So say like seed 128, that looks pretty good to me. Maybe we want to make it the scale a little bit bigger, or maybe a little bit less big so that it's not as crazy. And so this is pretty cool. So let's just say that this is like an exploding nebula or something, and maybe we want to make it like some crazy blue color. So let's go ahead into our scene. We will move this right here downwards. And so you can see that we've got this cool burst now. And then we'll just remove our checkerboard ground as well. So we've got this, And inside of our volume rendering, we can go into our fire color. So we will expose this to the graph. Let me just delete this VDB node. So we'll do this. And then what we'll do is we'll say it'll be like white at first, and then fade to a blue really quickly. And then we've got like a light blue or something like that. And so now we have this. But what we can do is, let's make sure that this right here is bright. And so probably want it to be more of a bright blue, like so. And then inside of our volume, you can tell that obviously there's not much brightness there, so you can increase your fire color. And if you wanted this to have more like, white values in it, we could bring this over and kind of extend these values here, maybe lower this color gradient to kind of match our fire. And we can also, oh, I'm mapping it to density, so that is what I'm doing wrong. There we go, there's a bright gradient. But if you want it to look more beautiful, so to speak, if you want it to look more beautiful, what we can do is we can increase our emissive contribution. And then we can also, where is it? We can go into our scene and we can change our bloom intensity to be a little bit brighter. And then also we can just change this to additive. So then it would be more of an additive particle. But for this particular effect, I don't like that we're spawning all the particles in just a random sphere. So what we'll do is we'll make the emissive type kind of electric. So now you've got this really electric explosion-like thing, which is really cool. And so, that could be a preset. That could be something that you do. If you want less initial burst or whatever, one thing we can do is we can change like our pressure random scale, which will kind of change how random our pressure works. You can increase that random intensity and kind of play around with it, or you can just use no pressure at all and just stick with your initial noise. Of course, in this noise, you can animate that value so that it randomizes, and you might want to go to something like 500 perhaps as your initial burst, and you might want to have less particles or something. So boom. So you can see that you just kind of play around and get this cool stuff going. We could experiment with using the clustered emission type, which is kind of funky, which I wonder, we have this simulation advection mode. I wonder, yeah, so it does look like it helps with the particle velocity by checking these two boxes, making them less prone to weird stuttering. And then inside of our emitter, we want to change this definitely to velocity aligned. And now we have a really cool, clustered explosion or entangled explosion or whatever. So this is a really cool burst. This would be great for a flipbook or some kind of wisps or whatever. So yeah, looking at questions real quick, nothing. Are you planning to add water simulations? No. It's going to be a separate tool called EmberGen. It's like Krakatoa, but real time. Yes, it is. Krakatoa was an inspiration for this. It's really, really cool stuff. I wish we could do Borderlands 3 and spice up the particle effects a little bit. I wish we could mod Borderlands 3 and spice up the particle effects. That'd be cool. Can you vary the cluster sizes? That is a good question. No, you cannot vary the cluster sizes, but let me write that down as a thing to add. Vary cluster sizes. 1 second. That's a really good suggestion. Okay, so there we go. So we've got that. It's cool entangled mode. And so that was one, really quick little thing. Let's say that we wanted to turn this into a shockwave. Right, so what do we do if we want to turn this into a shockwave? My best advice, if you want to turn something into a shockwave, is that there's really two routes, okay? So I'll show you the first route, which is by taking something like this and, say, increasing the advection and then having the particles collide on the bottom of the ground to create kind of like an artificial shockwave. So what we can do is we can add in some smoke weight, and then these particles will fall down. And let's boost this to like 2,500. And so now these particles should fall down pretty quickly. But we will move this right here down and move our noise maybe back to maybe like 75 or something. And so now we have this, and it kind of shock waves outwards, but it's not perfect, right? But you can see that these particles, once they hit the bounds, they do tend to like to expand. And so then what you can do is you can add in another force, say a line, and we want to push it, say, at 50, but we don't want to push it upwards like this. We want to push it downwards into the collision bounds. So what we can do is we can just, I think we can just do, say, 180 on X. Yeah, so 180 on X, and boom, now you've got kind of a line-like shockwave. And so it completely changes the effect if you view it from the top view. Of course, if you view it from the side, it's not going to be completely what you want, but now you do have this cool little shockwave. So yeah, so this right here is one way to do the shockwave effect. And in this case, it is how I did my poison effect. And that's how that one worked really. And so some extra details is, of course, this is more of a 2D effect and really only meant to be viewed from the top angle. However, you could also like throw in some noise here. So we can do like force noise and break up some of these lines as they're going through here. And we can kind of increase our scale, increase our amplitude, and get some crazier lines and swirls or whatever. So anyway, you can play around with that. So the second way to do one of these bursts, right? So you want to keep the ground collision, but on the line force, we'll just do no push force. We'll do a repel strength of, say, 50, maybe 150. And so now you've got an actual shockwave that's 3D, right? And so having it collide with the ground adds in some extra juice that you might want, right? Very, very video Copilot. Yeah, this is pretty video Copilot-y. So this right here is how you do more of a 3D thing, a 3D shockwave. And the higher you move your emitter, the higher these particles are going to go. You can see that this is kind of more like an ice burst. So what we can do is, if we wanted to make this more of an ice burst, just to show you some extra things, if we change this to per particle, you can see that it's super white now. Let's go ahead and boost our lengths here. So we can see this right here. It's pretty cool. We got our particles falling off the edge. If you do want to stop that, as I said earlier in the stream, you can change the bound type to kill. Yawning. All right, so yeah, so you change the bound type to kill, and then what we can do is over here in our volume, let's make sure that we change this to a radix sort, and then we want to change our shadowing intensity. And is this, let's see what our volume looks like here real quick. So in our volume, we've got this little thing. So not as crazy. So one thing to be aware of is how your volume is working. So you can see that our smoke gets stuck on the ground here. And we might want to make our smoke not die as fast. So that's actually in the simulation and smoke dissipation. We will lower that a lot. And so hopefully the smoke lasts longer, which it does in this case. And so then what we've got is we go back to our volume, change this to particles experimental, and now hopefully we do have some shadowing on this, but it's kind of tricky, right? It's kind of tricky to get the shadowing on this. And in this case, maybe you do want to use not per particle stuff, but volumetric. But in that case, you are stuck with the shading that was on said smoke. But anyway, but we can do per particle. And in this case, there's probably far too many particles. And so you could actually lessen the amount of particles that you are spawning. So we could do something like this. And let's see, even less. There we go. So something less. And then we've got that. And then if you wanted to, we can, of course, go to, say, our initial color. And what we'll do is we'll do random position based. And so we'll have them be kind of like an icy color. So we'll have like white, we'll have some blues, some brighter blues or whatever. Like, I don't know. We're just messing around. So we got something like this. And then with our randomized positions, and so we'll just do something like this to make sure that we have a good spread. Now you can see that you kind of have some, some kind of icy things. And you could, of course, go back to additive mode if you wanted to. And if you want to change your color boost, you can lower that, of course. So yeah, so that there is how you do like a shockwave. Kind of showed you an explosion. I can kind of break down one of my other explosions. It's like if we do this ignition gradient right here, of course the way that it works, which I think I got completely sidetracked and didn't even go over it. The way that this works is we've got it, starting with this gradient here. And if we look at our initial color, so let's see. So yes, our initial color is this. And we've got it so that it's, just completely white, and we're multiplying times this, and it's really cool. So that's how you get that cool gradient, is by changing the initial color over its life, and we just kind of ping pong through it to go back and forth. So really cool stuff. And like, let's say that, I had those particle trails that like rip through this. Like, let's say that we wanted to add this to it. We can just do it from scratch. So I will delete these other things. There's two ways to do it. So you can add in a collider. And so like, let's see if we add in like our shape primitive here, and we just blow this through, you can see that it is interactable with the particles. Way too much interaction in my opinion. But anyway, so there we go. We got this. We can do our particles. We want to maybe just disable our emitter for now. Whoops, emitter must be connected. Here we go. We'll change it on that. So now our emitter is disabled. And now inside of our collider, we want to show the collider. Okay, so here are our little colliding particles. We want to change this to a velocity cone. We'll do a maximum speed of say 75 and 45. Then from here we want to render with capsules, and we've got that. And then we want to make our particles shrink because if they're shrinking, then the velocity trail that it like drags behind it, it kind of like creates like a cone or an arrow or whatever. And that's what you want for some really nice fades. And of course, we want to change our min life to like 0.2 and our max life to maybe 0.3. And so now we have this, and our particles fade out really quick. So then with our cone, we just want to make it 180 degrees so that our particles just go everywhere. And then we want to enable our emission again. And now you see that we have this. We can kind of set it in the center right there. And we've got kind of a problem. Our particles are ripping through this a little bit too much, transferring too much velocity. So we can transfer, say, maybe 17% of the initial velocity, and carry that over into our particles. And then we can turn off show collider so that we can see what this looks like. Now you can see that we've got kind of an aerial burst. And so that's pretty cool, especially say that if we wanted to bring this explosion down onto the ground, right, and have like a ground-based explosion. And then over here, we've got our particles, and we want to bring those upwards as well. We can lower our cone spread radius to be upwards, and boom, you've got some really cool velocity. But what if you want those particles that are colliding, so say not necessarily be just a collider, but to be an emitter as well? And what if we did a separate emitter? So we can have a different particle type. Maybe it's all sparks, or it's using volumetrics or whatever. So if we go into the shapes, actually, we just plug this into our shape node. And so boom, now we've got these really bright particles. And what we'll do is we will do, of course, this right here is looking like it's already per particle. And we can do our initial color as a gradient. And so we'll go here to our color gradient, and let's do something just really funky just because we can. And so who knows what kind of explosion this is. It's a really funky one. And so we've got that. All right. And so then inside of this, I want to make it entangled because I really like making entangled emission types for this kind of thing. And so now you've got this like crazy thing, which if we made this more of like explosion colors, I think it could be really cool. So yeah, so you've got the particles that are going, and it's creating all these crazy strings. That is a really cool effect. And so yeah, so you can do something like that. And then of course, if you wanted to, you could keep this collider so that it is blowing through the particles and creating those crazy strings or whatever. So yeah, that just shows you just go through and you iterate. Would be interesting to see what this looks like as a volumetric explosion. A bit on the low res side, but it is interesting nonetheless. Of course, if you wanted to improve the looks of this, you can do your sharpen, which comparatively, the particles look much, much better initially, and then they kind of suck. So I think it's going to be really great, which they suck once it gets out because it spreads out and it's all grainy and stuff. So that's where like your hybrid modes come in. So say something like this, then you have that, and then you've got like some smoke and stuff too, and these particles could fade out faster or something. But you would need a really high resolution sim to match the initial quality of that initial burst there. So then you can do like your regular entangled or whatever, and that's kind of the basics, you know. That's how you mess around with EmberGen and do cool things, and yeah, that's the basics. Any questions? I'm gonna end the stream here soon. Any questions? Let's see. So yeah, just for the stream's sake here, we had a question that was like, will you be able to save the particle attributes as like a JSON file or something? Yeah, we hope to support like a Leanbic or JSON files or whatever, so that you can import these particles into other tools. That is planned. Could entangled mode do electricity lightning effects? Yes, if you're patient. I say if you're patient because, like, let's say we do this poison shockwave or something, maybe we like reduce this force or something. So say we have something like this, right? It's kind of light and boldy. We've removed all the initial noise and it kind of sticks to it. So what you would need to do is, which I don't know if I'm going to be able to do it quickly, but basically we'll just say something like this, and then we'll have something that's black, and then we'll have another black, and then we'll just create a bunch of black ones here. So then we need to do like a blue, like so, then bring over another black. Okay, so be patient with me. I will try and get this to work. Okay, and so you will see what I'm doing here shortly. And let me go ahead and move some of this stuff to the beginning. Actually, where's it at? Okay, so yeah, so all blue. And so we'll move here. We got our initial black. So it looks like this right here is doing our color over life. I need to make sure that this is per particle. There we go. So now you can see it kind of flashing through and doing its thing. And so what we'll do is we'll make sure that we keep on doing this. And so here we go, another blue, the very tedious gradient. Add in another blue. And just keep on doing that, and the particles will flash. So here we go, add in some space. And then what you can do is you have it like not be as bright, and then you can see that it kind of flashes. And if you want to increase the time steps between your flash, essentially what you do is, which it looks like it's using this first gradient here. So we can kind of bring this over and bring this here. And so yeah, so kind of electricity-y. And the longer your emission is, they kind of flip-flop and change. And so you just have that. You have all these like pulses in your gradient, and that will create your lightning. So I'm not going to go through it because it's really tedious, but that is how you do it. Loving this tool so much. Been messing with it all morning. Thank you. If you reduce the particle count, you might get more of those electric looking tangles. It is possible that you could. Let's see. Yeah, so there you go. That is a little bit more electric, especially if we really reduce it. Then you get some some pretty cool stuff. But like you see, once you get like really far into it, the force, I guess, let's see, what is it doing? It's like slamming these into the ground. Like if we did that last, and say with our line, we just did a repel strength, you know, maybe, hopefully in the future we can have like more of a lightning thing. I would like to have like an actual lightning tool in EmberGen too, to create like weird lightning bolty things, because it is really useful for a lot of applications, I think. But yeah, so you can see that you can, you know, funk around with this thing and do whatever. Of course, you could do like your particle emission shapes or whatever, and kind of, you know, let's see, really increase these things. We've got like a ball of lightning over here. It's like a burst wave of particles. Might want to increase the emitter for this one. So there you go. And so yeah, it just kind of depends on what you want to do for this. This is it. The update I've been waiting for. Time to buy EmberGen. Thank you. Yeah. Well, I mean, we are kicking ass with these updates. There's so much more to come. Camera imports and meshes or animated meshes and backplate imports and better flipbooks, a brand new UI, all kinds of stuff. You know, more GPU particle features. So much is going to happen. Yeah, so any expected live link with a game engine? Yes, you can expect a live link. That is our plan. The eventual goal is to have EmberGen be the particle editor, fluid simulator, all that stuff, and then have it live link into Unreal and Unity and maybe a custom game engine if a studio wants to pay us, and have that in, and then you just tweak in EmberGen, automatically updates and is dynamic and all that stuff in Unreal one day when all these simulations can be supported. So definitely planned to support fluid sims and all that shit and game engines. It's just a matter of time, really. We've got more people that we're hiring and have hired, and so a lot of that's coding help, and so we'll get there faster than ever. Yeah, so I think that's it, guys. I'm gonna go ahead and end the stream here. I don't really have anything else to show, so you know, have a great time, have fun. Check out all of our GPUP presets. So GPUP, those are all the particles and stuff like that. You can do really cool fire, you can do explosions and smoke. Also still use our volume renderer, you know. That thing is not dead, it's not going away. There's a lot of cool things that you can do with the volume renderer like this that you can't do with particles. So keep it in mind, you know, this is just another tool in your arsenal. You know, I'm really glad that you guys were on the stream, and I hope you have a great day. Gonna do that awkward moment where I wait for the YouTube to catch up before I end the stream. I think I'm gonna end it now.